Walk into a modern classroom today or, just take a look at your own desk right now. Picture the scene.
Right.
You likely see the soft, cool glow of glass screens. You hear that quiet, rhythmic tapping of keys. Tablets have steadily replaced the battered spiral notebooks we all used to lug around in our backpacks.
Oh, yeah. Sleek, brushed metal laptop sitting exactly where heavy, overstuffed binders used to be.
Yeah.
I mean, it is a scene that just a single generation ago would have looked like pure science fiction.
It really would have. And, we have engineered a world where information has just never been easier to access. It's never been easier to organize into neat little digital folders or to share with someone halfway across the world in, like, a fraction of a second.
Yeah, the advantages of this digital shift are completely undeniable. The sheer volume of ideas we can process daily is, well, it's staggering compared to the past.
The convenience is incredible. But as you watch fingers flying effortlessly across keyboards, or as you swipe your thumb across your own phone screen, you might notice something physical missing from the picture.
Right, handwriting.
Exactly. Handwriting is quietly disappearing from daily life. I mean, even very young children are getting entirely comfortable with a keyboard long before they ever manage to master cursive.
Yeah, they really are.
So we gain this enormous sweeping convenience, but you have to wonder if something profound is quietly slipping out the back door while we're all, looking at our screens.
It's a fair question.
Right. To figure that out, today's deep dive is pulling from a fascinating stack of neuroscience journals. We've got a new Norwegian study and a classic piece of UCLA research.
Both really fascinating pieces of work.
Yeah, and the mission here is to answer a question that actually affects every single one of us. What actually happens to the human mind when we stop writing by hand?
Well, on the surface, producing a text seems like the exact same task whether you use a pen or a keyboard.
Right, you want a word to exist. You make the word appear on a page.
Exactly. The output looks identical. But if we look beneath the skull at the biological level, that assumption falls apart completely. Yeah, it shatters the moment you examine the neural activity. There's this 2023 study from the Norwegian University of Science and Technology, published in Frontiers in Psychology.
Okay.
And they mapped out exactly what happens inside the brain during these two different activities. Researchers placed these high-density EEG caps on participants.
Just to track their brainwaves while they wrote.
Yeah, exactly. They had them perform similar writing tasks, some typing on a keyboard, some writing by hand with a digital pen on a touch screen. And the way the brain responded was just dramatically different.
How so? Like, what was different about it?
Well, writing by hand produced this incredibly widespread coordination across the brain. We're talking about regions responsible for physical movement, for vision, for physical sensation, and memory.
All lighting up at once.
Yes. All lighting up and talking to each other at the same time. The researchers saw these massive increases in connectivity. It was a huge synchronized neural event happening just to write a simple sentence.
Wow. And what about the typing group?
Typing generated significantly less of that large-scale connectivity. The brain simply did not engage in the same widespread, coordinated way.
Yeah.
The visual areas, the motor areas, the memory centers, they just weren't communicating with each other across those broad networks like they were with handwriting.
Okay, but at first glance, you might think, well, so what? I mean, both actions get the words onto the page.
Right.
If I type the word hello or write the word hello, the end product is identical for the person reading it. Why does it matter if my brain uses fewer regions to get the job done?
That's the logical question.
Honestly, it almost sounds like typing is just more efficient for the brain. And we usually celebrate efficiency.
We do, yeah. But the brain is not a factory churning out a final product. The brain is actively shaped by the process of creation itself.
Shaped by the process. Okay, explain that.
When you write by hand, the brain is forced to process the physical sensation of the pen, the resistance of the paper or the screen, the visual feedback of the ink forming specific shapes,
Right.
and the complex motor commands required to make it all happen. Typing bypasses almost all of that sensory and motor integration.
Because you're just pressing a button.
Exactly.
Yeah.
You press a button and the machine does the drawing for you.
Huh. So it's kind of like, think of typing like writing in a taxi.
Yeah.
You get to your destination quickly, and you didn't have to put in much effort, but you weren't really paying attention to the turns.
Right. You don't know the route.
So you don't know how to get back there later. Whereas handwriting is like driving the car yourself in a new city. It's slower, it's frustrating, you might miss a turn.
Yeah, you have to pay attention.
But the physical act of steering navigating, and constantly adjusting that builds a permanent spatial map in your head. You own the route because you drove it.
That is a brilliant way to put it. The brain actually cares deeply about how the word is made, not just that the word exists at the end of the process. The mechanism matters fundamentally.
So the mechanism is doing the heavy lifting for the brain.
Exactly. And if we want to understand why that mechanism matters so much, we have to look at how human beings learn processes in the first place.
Like when we're kids.
Yeah. Watch a toddler learning to walk. It's this fascinating, chaotic process. They don't sit down and read instructions on bipedal motion.
Right, they just go for it.
They learn through sheer movement, endless repetition, and this truly impressive willingness to just fall down over and over again.
They learn balance specifically by losing it.
Yes.
I mean, the same logic applies to so many early skills. Children learn how to stack wooden blocks by inevitably knocking them over.
Exactly.
They learn physical coordination by reaching for things, grabbing, climbing, misjudging distances, and constantly adjusting based on the physical feedback they get from the world around them.
Right, because learning isn't just this isolated, abstract thing happening inside a vacuum in the skull. It's an active, ongoing conversation happening between the brain and the body.
And handwriting is part of that conversation.
It appears to be a critical part of it, yes. When a child is learning to write the letter A, they aren't simply copying a symbol. It's a highly complex physical and cognitive task.
Oh, because of all the different muscles involved.
Right. To draw that A, they have to plan a physical movement, control the tiny muscles in their fingers, grip the pencil with just the right amount of pressure.
Monitor the visual feedback of the line on the paper.
Exactly, and then adjust their direction in real time. The brain is simultaneously connecting what the child sees, what they think, and what they are physically doing.
Wait, let me make sure I'm picturing this right. If I'm typing, hitting the A key requires the exact same micro movement as hitting the X key or the M key. I am literally just tapping a square. But writing an A versus an X by hand requires entirely different muscle choreographies. Is that difference what's signaling the brain to pay attention?
Precisely. You aren't just copying a shape. Your motor cortex is literally driving a different route for every single letter. The effort is drastically greater. Every time a child writes a letter, they're building it from scratch.
Well, okay, I have to admit, looking at the demands of the modern world, this is where I get hung up.
How so?
I look at kids today, and they can type 60 words a minute on an iPad by the time they are in middle school. If digital fluency is essential, and we all know it is, and typing is objectively faster and cleaner, why force a child to struggle with a wooden stick?
Well,
I mean, isn't the whole point of human progress and technology to remove friction? If a kid can just tap a key and get the A, they can focus entirely on their ideas, their stories, their creativity, instead of wrestling with the physical mechanics of holding a pencil. Why are we so nostalgic for the struggle?
I hear you, but we need to fundamentally redefine how we view struggle in the context of learning.
Okay, redefine it how?
Modern life operates on the broad assumption that easier is inherently better. We view physical friction as a bug in the system, something to be engineered away so we can be more efficient and productive.
Right.
But in human development, the struggle isn't a problem to eliminate. The struggle is the actual mechanism through which learning happens.
The struggle is the mechanism.
Yeah. Deliberately making something harder just for the sake of it seems counterintuitive to everything we try to do with technology. But in cognitive development, it's not for the sake of it. It is for the structural development of the mind.
So the inefficiency is actually doing structural work beneath the surface.
Exactly. The inefficiency is building the neural pathways. Think about the most important early developmental milestones. They are all built on activities that are deliberately, intensely inefficient.
Like crawling.
Yes. Crawling is an incredibly slow and inefficient way to move around a room, but the cross-lateral movement is entirely necessary for brain development before walking.
Oh, wow. I didn't think about it like that.
Scribbling chaotic nonsense on a page is necessary before writing. Sounding out words syllable by agonizing syllable is necessary before reading fluently.
So we shouldn't just skip to the easy part.
Right. This doesn't mean children should avoid technology. Digital fluency is non-negotiable today. But replacing handwriting entirely removes a crucial physical experience that the developing brain actively uses to wire those regions together. The physical friction is the signal that tells the brain, this is important, remember this.
You know, watching a kid struggle to draw an A makes sense. They're building the hardware. But, I mean, I'm looking at my own desk right now. I'm looking at my laptop.
Yeah,
My brain's hardware is already built. I know how to walk. I know how to stack blocks. I know how to write my letters. Does this physical friction still do anything for me? Or did I age out of the benefit? Do adults just get a free pass to type everything?
That's a great question, but no, adults are not exempt from this dynamic.
Really?
Yeah. The cognitive benefits of that physical friction do not just vanish the moment we leave childhood. We see the exact same principles at play in how adults process and retain information.
Give me an example.
Consider how you might take notes right now. Say you're in a meeting or at a conference or listening to a complex lecture. If you are typing on a laptop, the natural tendency is to drift toward pure transcription.
Because typing is so fast.
Exactly. You can actually attempt to record a speaker verbatim. You end up trying to capture the words as fast as they arrive.
Yeah, you essentially turn into a human court reporter. Your only goal is speed and accuracy of the transcription.
Right. But handwriting operates under a severe physical constraint. You simply cannot write as fast as someone speaks.
No, definitely not.
Because you cannot write down every single word, your brain hits a physical bottleneck.
Which forces a totally different kind of mental engagement. When you write by hand, you're engaging your working memory to hold the speaker's thought, your semantic memory to comprehend what it actually means, and your motor cortex to summarize it onto the page.
You're literally building a new neural pathway in real time, whereas typing just routes auditory input straight to your fingertips, bypassing the processing centers almost entirely.
Wow.
Researchers call this the generative effect. You are generating your own understanding of the material as you consume it. A famous study from Princeton and UCLA looked at this exact scenario.
The laptop versus longhand study.
Yes. They compared students who took lecture notes on laptops with those who took notes by hand. And they didn't just look at how many words they wrote. They tested them on both factual recall and conceptual understanding.
And what happened?
The results were striking. The students who took longhand notes retained conceptual understanding significantly better than those who typed.
Even though the typists recorded far more words.
Yep.
The people with fewer words in their notebooks actually understood the underlying concepts better.
The typists had a better transcript, but the handwriters had a better understanding. The act of having to process the information, rephrase it, and physically write it down heavily deepens comprehension. The physical constraint forces the brain to digest the material.
Think about your own habits for a moment. You probably notice you remember things much more clearly when you write them down on a sticky note or in a physical planner or a journal.
It's so true.
And the secret ingredient isn't the physical paper. It isn't some magical property of ink. The reason you remember it is because of the deeper cognitive work required to make those notes in the first place. You had to work harder for it, so your brain kept it.
Yeah, and what's fascinating here is that this research about handwriting isn't really just a debate about pens versus keyboards. It points toward a much larger principle, something older and far more fundamental about how human beings operate in the world.
We appear to learn and retain information best when thought is directly connected to action. When the whole body participates in the process, not just the very tips of our fingers tapping on flat, frictionless glass.
We see this pattern everywhere. Children discover the world naturally through physical play. Adults experience it anytime we engage the body to learn something new.
Like learning an instrument.
Yes. You do not learn the guitar by reading a manual. You learn it by building calluses on your fingers and forcing your hands to make awkward, difficult shapes until the muscle memory takes over.
Or a language. If you're learning a new language, you have to physically form your mouth around unfamiliar syllables. The mind and the body have to sync up to master it.
Precisely. Technology offers us remarkable, life-changing convenience. But convenience sometimes strips away the very friction that helps us think critically, remember deeply, and adapt to new information.
Because when we make everything completely effortless, we risk losing the cognitive depth that comes from physical effort.
Yeah. And the goal of all this isn't to reject keyboards. Keyboards are essential tools for modern life.
We're not throwing away our laptops.
No, the goal is perhaps to simply preserve some activities in our lives that ask a little bit more of us than just pressing a button. To keep a place for the slow, inefficient processes that actually build our understanding of the world.
It's about recognizing the hidden value in the physical struggle of creating something by hand. It forces us to slow down, to be present, and to engage our entire nervous system in the act of creation.
Exactly.
It makes you wonder, if physical friction builds our neural pathways, If struggling to form letters or summarizing complex thoughts by hand is what actually wires our brains for deep understanding, what happens to us when everything else becomes effortless too?
That's a profound question.
What happens to a generation's ability to navigate emotional friction or complex social friction if their primary interface with the world becomes completely frictionless? Something to think about the next time you reach for a keyboard to jot down a thought or a plan or a memory. Consider picking up a pen instead.
The words will look the same when you're finished, but inside the brain, something richer will have happened.